So earlier we calculated how much to adjust these weights with respect to the output error here. Yeah, so based on this output error, we calculated how much to adjust W7 with respect to that error, how much to adjust this with respect to that error, and also how much to adjust W9 with respect to that error. So the next task ahead is to also see how much to adjust these weights with respect to the errors EN3, EN4, and EN5. And as you can see on my left-hand side, you can see now how much to adjust, how much do we need to adjust W1 such that EN3 is reduced. So this equation would help us solve that. You can see minus EN3. So we're looking at how much to adjust W1. So W1, we would have to look at the error in front, and then we would also have to look at the output from N1. And you can see that's the error in front, and then the sigmoid here is what we have here. You can see the sigmoid S1 here means, I'm sorry, S1 here means sigmoid N1 times W1, so that is N1 times W1 plus N2 times W2. So that gives our S1 dot the output from the previous node. So anytime you want to adjust W1, you would have to look at the error in front and then the output from the previous node. And that's what we did for W7. Remember, we looked at the error in front of it, which is the 0.44, and also the output from a previous node. So here we're calculating W1, then we'll have to look at the error in front. So the error in front is EN3, that's we have in EN3. And then we have our S1, and S1 means N1 times W1 flowing into N3, and then N2 times W2. So that's our S1. And then you multiply that by N1. So N1 is the input to N1 because that would flow, that flows inside. Remember, we don't need any sigmoid here. This node takes in the input value. And then if you also want to calculate how much to adjust W2, W2 would also have to look at the error in front of it. And then we'll also look at what flows outside, and what flows inside and outside the previous node here. That is EN3. And then S1 would also remain the same because that the N1 times W1 plus N2 times W2, the flow into this node. And then this node also has that error. And then we'll reckon with that error. Here's the EN3 S1 and then times N2 in this case. And then the same thing goes for how much you need to adjust W3 such that error EN4 is reduced. See that's error EN4. And then we're looking at W3. So W3 would also have to reckon with the error in front of it and also the node and the output from that node, N1. So you can see minus EN4, that's the error in front of it. And S2 here means, you can see S2 here means N1 times N3 plus N2 times N4. So you look at the nodes that connects to this node. I'm sure you know that this node has error EN4. So you reckon with that. So N1 times W3 and then plus N2 times W4. N1 times W3 and N2 times W4. And then with that, this would give us how much to adjust W2. Are we on W? Yeah, W3. How much to adjust W3 such that EN4, the error EN4 is reduced from 0.044 to, for example, 0.040, for example. And then the last, you also have how much do we need to adjust W4 such that EN4 is also reduced. Same thing too. We have our error in front of EN4, and then we'll also reckon with N2. So N2. So you look at the error in front of the weights you're trying to adjust, and then you also look at the previous node, the output from a previous node, so that you can see dot N2. And then we've defined S2 here, same thing goes. And lastly, not second to the last, we have how much do we need to adjust W5? So W5 will also look at the error in front of it, which is EN5. And then you look at the output from the previous node, which is N1. See? And then you have our S3. S3 here is sigmoid N1 times N5, and then N2 times N6. So that's our S3. And lastly, we have the E. So this should be EN5. Yeah. So how much do we need to? This should be EN6. So apologies for that. This should be EN6. Am I right? No, EN5. EN5. We're right. EN5. So this should be how much do we need to adjust? Let's see. Yeah. So how much do we need to adjust error N5 with respect to W6? So if we nudge, if we adjust W6, how much will it reduce EN5? And that also is what we have here. We have EN5, and then S3, we have defined S3. And define ES3, and then N2 here now. So for W6, we look at the error in front of it, which is EN5, and then the output from the previous layer, which is N2. And then we can also merge this and convert it into a matrix, into a matrix format. And then you can see, so this times this give you how much to adjust W1. This times this will give you how much to adjust W2. This times this tell you how much to adjust W3. This times this will tell you how much to adjust W4. This times N1 will tell you how much to adjust W5. And lastly, this times this tell you, sorry, this times this would also tell you how much to adjust W6. So in our next video, we'll begin to do the implementation. Thank you very much. See you in the next class.